Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 17, 2025, just yesterday. This paper introduces a self-evolving training pipeline for graphical user interface automation that claims over 90% annotation accuracy at 10 to 100 times lower cost. And it trains StepGui 8B to hit 80.2% on Android World, 48.5% on OS World, and 62.6% on ScreenSpot Pro. The paper is titled StepGui Technical Report, and as we will see later, it also tackles privacy and deployment with a standardized protocol and a new everyday use benchmark. Also, the authors shared a companion GitHub repo for GE Lab 0, which is essentially the open source GUI agent stack behind the report. You will find the agent client and server, an MCP server for multi-device task distribution, examples to run single tasks, setup scripts, configs, and a Streamlit tool to visualize interaction trajectories end-to-end. Figure 1 makes the main claim concrete, which is that StepGui competes strongly across very different graphical user interface benchmarks. This figure shows 5 bars charts that split into grounding tasks, meaning precise on-screen pointing, and end-to-end tasks, meaning finishing multi-step goals. The StepGui bars are the blue ones, and the StepGui 8B bar is typically the tallest. Pass at 3 means the agent gets 3 tries, so random crashes do not dominate the score. Table 1 explains how training shifts from broad exposure to targeted fixing of mistakes. This table summarizes the full data mixture for mid-train versus cold start, so you can see what gets emphasized when the model starts failing on real trajectories. Cold start is much smaller overall, but knowledge becomes the largest slice because the team injects missing facts as question answering pairs. The mid-train side also includes action alignment and environment-specific data, while cold start drops both. Figure 2 explains why the training data flywheel stays reliable, even when the model explores and makes mistakes. This figure shows the full calibrated step reward system pipeline, where trajectory level validation means judging the whole attempt as success or failure, so rewards stay high confidence. The central block splits into a calibration layer and a data extraction thinking model that turns trajectories into 7 training data types. The 2 right panels summarize the stability advantage and the richer step-by-step reasoning advantage, which then feeds back into training. Figure 4 explains how the system actually talks to real devices, while keeping control efficient and private. This figure shows the full GUI MCP architecture, which is a standard protocol that connects a cloud large language model to phones and desktops through a consistent tool interface. The top panel splits high-level task delegation from low-level atomic actions, so the server can adaptively choose between them. The bottom panels highlight fewer calls and high-privacy text-only sharing. Table 4 shows that the StepGui models stay competitive when the task is full end-to-end interaction, not just pointing at buttons. This table summarizes both pass at 1 and pass at 3, which means the agent gets up to 3 attempts, so random virtual machine crashes do not dominate the score. The left results column on OS World Verified highlights StepGui 8B at 48.5 on pass at 3. The right results column on Android World shows StepGui 8B reaching 80.2 on pass at 3. Table 6 shows how well the agents actually finish real, multi-step daily phone tasks, which is a tougher test than single clicks. This table covers the full Android daily end-to-end results. The left block breaks success down by task type, where query tasks score highest because they are mostly retrieval. The middle block splits complexity, and composite tasks drop sharply because planning long action chains is hard. The right block shows ambiguity, where StepGui 8B does best on high ambiguity. Alright, 2 takeaways stand out. The calibrated step reward system creates a practical data flywheel, turning messy model rollouts into reliable training signals at far lower labeling cost. The other big implication is deployment readiness, because GUI MCP pushes towards standardized, privacy-preserving automation where sensitive screens can stay on device. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.